It's time to take attendance. Luria? Trillion? Here. Zio? Zio? Does anyone know where Zio is today? Zio was last seen in your vicinity.
Don't look at me. I didn't do anything. I'm innocent. Innocent, I tell you.
Guys, I'm over here.
You're not in your assigned seat.
I moved. Trillion had stinky moon cheese for lunch.
I don't smell anything.
Zio, you're not in your assigned seat. It's not the same.
It is the same. I'm just in a different seat.
Good point, Zio. Today's lesson will illustrate your point exactly. Look closely at the following sums. Keep watching. What did the models demonstrate?
When adding the same numbers, it doesn't matter what order they're in. The sum stays the same.
Indeed. This is called the commutative property of addition. The order does not change the result.
Okay, you should go ahead and write this down in your notes, your property play notes. The commutative property of addition. What this says is when you add any two numbers, the order does not change the result. Once you have that written, please come back and press play. Also, just so you know, whenever it says A plus B equals B plus A, they are using variables here. Those variables could be any rational number, and it would be a true sentence. And we will do plenty of examples to show you that.
Here's another property of addition. Watch one more time. What do these models show?
The way you group numbers when you add does not change the sum.
That's correct. This is the associative property of addition. When you add numbers, the way that you group the numbers does not change the result.
Okay, this is another one where you should go ahead and write this down in your play. You can press pause and then write this down and then come back. What this is saying is that you can put any numbers together and group them any way you like, and as long as it's the same three numbers or same multiple numbers, it doesn't matter, the answer will be the same. I like to think of associative property as a grouping property. Associate means to meet up with or hang out with. So I like to think about like if A and B are hanging out together and C is on the outside of that group, it's still the same three people, even if the next time it's A hanging out on the outside and B and C hanging out together on the inside. It's still the same three people, A, B, and C. And we'll do more examples of that also. But make sure you write this down. When you're done writing it down, go ahead and press play again.
So, to find the sum of 3 plus 4 plus 5, we could add the sum of 3 and 4 to 5, or we could add 3 to the sum of 4 and 5. If we add 3 plus 4 first, we get 7 plus 5, which equals 12. If we add 4 plus 5 first, we get 3 plus 9. 3 plus 9 equals 12. So the sums are equal. We get the same sum no matter how we group the numbers that we're adding.
I get it. Different problems, same answer.
Just like with my parents.
What do you mean?
I keep trying new ways to ask my parents for an increase in my allowance, and I always get the same answer.
Let's move on to another property. The identity property for addition states that the sum of a number, when added to 0, is that number. For example, 6 plus 0 equals 6, and 0 plus 8 equals 8.
Hopefully you guys noticed that when you did your own property investigation. Hopefully you realized that when you add 0 to any number, no matter what kind of number, a fraction, a negative number, a decimal, a whole number, it doesn't matter. When you add 0 to a number, it will always equal the same number. That is the identity property of addition. You want to go ahead and write that on your notes as well in the property play. I'll be rewriting this for you too, just to make sure you have it, but that's also very important.
In problem 1 of your lesson notes, name the property shown.
Okay, take a look at this problem. 12 plus 35 equals 35 plus 12. Hopefully you answered yourself when you were taking notes. Hopefully you wrote an example down, and hopefully you would write that that is the commutative property. That should be the commutative property of addition. Hopefully you wrote that down as well.
If you add in different orders, you get the same sum. That's the commutative property of addition.
You're right.
Let's do another practice problem.
In problem 2 of your lesson notes, what property is shown?
21 plus the quantity of 3 plus 4 equals the quantity of 21 plus 3 plus 4. Hopefully you can look at this and figure out what property this is. Go ahead and press pause and write down yourself in your notes what property you think this is. Please write the whole example down and the property that you think it is next to it. When you're ready, press play. Okay, hopefully you said that this was the associative property of addition. This is the grouping thing again. Let's say, for example, that we have you working in groups, and for the first math problem, 3 and 4 are working together and 21 is checking the results. The second problem, 21 and 3 are working together to solve the problem, and 4 is checking the results. It's still the same 3 people or the same 3 numbers hanging out together, 21, 3, and 4. They just might be seated differently or have different roles. Good job.
In these additions, the numbers are grouped differently, but the result is the same. That's the associative property of addition.
Excellent. In problem 3 of your lesson notes, name the property.
Okay, this is a little bit trickier. I want you to really look closely at this problem and see if you can figure out what property is being shown. Now, I do want to give you one hint. Just because you see parentheses does not always mean it's the associative property. The associative property is when the people or the numbers inside the group change, but the same numbers are involved on each side of the equation. If the group has not changed, it may not be the associative property. So take a close look at this problem and see what you think. Press pause and write this down. Write this example down in your notes and write down what you think it is. Press play when you're ready to check your answer. Hopefully you looked very closely at this problem and noticed that the actual groups did not change. What changed was the order of the number inside the groups, so that means that this is the commutative property. Okay, it's the commutative property of addition.
Numbers in the parentheses has not changed, but the position of the parentheses has changed. This is the commutative property of addition.
Very observant, Trillian. In problem 4 of your lesson notes, what is the property?
Okay, press pause and try to guess the property. Write the example down in your notes and guess which property it is. When you're ready, press play. Hopefully you noticed this one right away and that this is the identity property. Let me erase that. This is the identity property of addition. Okay, that property says that you can add 0 to any number and the number will not change. So 3 plus 0 equals 3. It's like the number is looking in a mirror and seeing itself. You add nothing to yourself and you're still yourself, right? Nothing has changed.
When you add 0 to a number, you get that number. The identity property of addition.
Nice work.
Okay, we're going to stop this here now and go right to your note sheet, the property play, and I'm going to help you fill out anything that you may not already have had. Okay, so we already started with the commutative property of addition. The commutative property of addition says that A plus B equals B plus A, and that is true for any numbers. So let's write a few examples here. We wrote whole numbers already, so we could say 3 plus 4 equals 4 plus 3. They both equal 7, so this is true. We could also use a fraction. We could say 1/2 plus 1/4 is the same thing as 1/4 plus 1/2. We just switched the order of the numbers, but the answer will be the same. 1/2 plus 1/4, you should know, is 3/4, and 1/4 plus 1/2 is also 3/4. Okay, go ahead and add another page, and you may have more room than I do, but let's go ahead and add another page and do a few more examples. What if we have negative numbers? What if we have integers and we have negative integers? A -3 plus a -2, does that equal a -2 plus a -3? It should, but let's just prove it. -3 plus -2 is -5. -2 plus -3 is -5. Remember, the balloon starts at a -3. If we add 2 bags of sand, the balloon will go down. It's the same thing if we start at -2 and add 3 bags of sand, we will still go down to -5. It's true. Is the commutative property true for decimals? I think it is, but let's prove it. 2 plus 1 plus 4 plus 3, 4.3, sorry, is the same thing as 4.3 plus 2.1. Okay, we can prove that by saying that that is 6.4 still equals 6.4 over here. All true. Now, does the commutative property work for subtraction? Let's see. Does 2 minus 1 equal 1 minus 2? 2 minus 1 is 1. 1 minus 2 is the same thing. KFC, 1 plus a -2 is -1. So this is not true at all. Let's make a big red not equal and write commutative does not apply to subtraction. I'm running out of room. Let's see if I can make some more room. Okay, you guys will probably have more room than me. Okay, oh, it's not showing up on my screen, is it? Let's try to make that a little bit bigger than for you, because that was not showing up. I'll add another page. There was a little bit of a lag there, so I'll write it again. 2 minus 1 does not equal 1 minus 2. They are not true. So it does not, commutative property does not work for subtraction. does not apply to subtraction. Okay, let's go ahead and do the associative property next. You probably have a lot more room than I do, but I'm going to just use another piece of paper so I have enough room. The associative property of addition. Okay, this is our grouping property. You may want to write grouping underneath here so that you remember that this is the one that refers to groups. Okay, this simply says that A plus B plus C equals A plus B plus C. You can change the groups. Okay, you can change the groups around. Now, does this work for all types of rational numbers? Yes, it does. Let's try an example with integers. -4 plus the quantity of a -5 plus a -6. Does that equal -4 plus a -5 plus -6? Well, let's just check it out and see if it does. -5 plus -6 is -11 plus a -4 equals -15. Let's check it out and see if it's true over here. -4 plus -5 is a -9 plus a -6. Negative plus negative is always negative, no matter what. So a -15 equals a -15. That is true. Will it also work for fractions? Let's see. Okay, let's write this down. How about 1 1/2 plus 1/2 plus 2? Does that equal 1 1/2 plus 2 plus 1/2? Well, let's see. 1 1/2 plus a half is 2, plus 2 equals 4. Is that the same thing as 1 1/2 plus 2, which is 3 1/2, plus a half, which will also equal 4. So that is true. It checks out. Okay, associative property will not work for subtraction. It's just like the commutative property. It does not work. Let's write that down. Associative property does not apply to subtraction. Okay. Go ahead and add another page and we'll just talk about the identity property. Okay. Our identity property of addition simply says that A, for any number, A plus 0 equals A. And A can be any rational number. That means it can be an integer, a decimal, a fraction, whole number. It doesn't matter. They all work. If you add 0 to any number, it will always be the same. Okay. The only other thing I wanted to show you is I just want to show you a real quick visual to help you with the commutative property, especially with the negatives. So let me just add one more page, and I'm going to do I'm going to write a little number line here. Okay. And I'm going to write the problem -2 plus 4 and show you that on a number line. Okay, if I start at a -2, okay, if I start there and I add 4 units to that in a positive direction, because it's a positive number, this is like my balloon starting at -2, and I want to go 4 units in a positive direction, 1, 2, 3, 4, okay, plus 4, I land at 2, okay, so that equals 2. Let's prove that it's true with the commutative property. 4 plus a -2, does that also equal 2? Now it's very important when you switch your numbers, when you're using the commutative property, if you're talking about positive and negative numbers, you must keep the sign with the number, okay, when you switch the order. Okay, so we would start here now. We would start at 4, okay, and we would go -2, or we'd go 2 units in the negative direction. So we would go 2 units in the negative direction plus a -2, and we land at 2. So it is true, the commutative property works, but we must keep the signs with the number. So let's make sure we write that. Must keep signs with numbers when we switch. Okay, I hope that the robots helped you understand the commutative, associative, and identity property a little bit better, and I hope you took some very good notes. Please make sure you email your notes to your teachers, Mrs. Bino or Miss McCauley, when you finish, and answer the 2 questions in the note check. Bye for now.